Welcome to the first episode of the complete deep learning series. In this video, we'll be exploring the concept of deep learning, what is it, and how it really works, some possible applications, and some challenges. So without further delay, let's get started. So what is the true purpose of deep learning? Deep learning is a field of artificial intelligence and the subfield of machine learning, where machines are able to learn and improve by experience, without someone coding it explicitly. Deep learning comes under machine learning, which is inspired by the structure and function of the human brain. A human brain consists of billions of neurons, roughly around 100 billion neurons, connected to each other. These neurons communicates and send signals with each other, makes things possible for us, including recognizing this as a dog and this is a cat. So can we simulate the properties of these biological neurons to a machine to make them intelligent as humans? The answer is yes. This is where deep learning comes into the scene, by simulating the properties of the human brain to a machine using algorithms. This can be possible by building a neural network like the brain, known as an artificial neural network or simply ANN. An artificial neural network has many number of interconnected neurons, or we can call them nodes. These nodes activates when a high input threshold is reached, just like biological neurons. And the activated neurons send the signals to the next corresponding neurons. Between each of these neurons, we assign some weights to determine the strength of each connection. So these weights are basically the hearts of artificial neural network, which can be adjusted as per the input data. Here is a simple neural network with some inputs and weights. Here we have 2 input neurons, 3 hidden neurons, and 1 output neuron. As you can see that the high input corresponding to weights 0.5 and 0.2 makes activation in the top neuron of the hidden layer. This excited neuron will send a high output value to the output neuron and the desired output is produced. This is just for a basic understanding of its working. Neural networks are often more complex when the number of neurons and layers grows. One more thing to understand, an artificial neural network have one input layer and one output layer, but it can have as many hidden layers. All the crazy magic of artificial neural networks happens inside these hidden layers. These hidden layers became black boxes when the number of neurons and layers inside a network grows. So we cannot understand what really happens in these hidden layers. This is one reason that there is no idea how a neural network comes to a conclusion of recognizing a dog instead of a cat. When the number of hidden layers of a neural network grows, it became something known as a deep neural network. Deep learning is all about building and training these deep neural networks, and its different variations for getting desired results. Deep neural networks are often used in image recognition, speech synthesis, voice modulation, and lot more. So that's it about neural networks. More about neural networks will discussed in the upcoming episodes. Right now, let us discuss some of the applications of deep learning. Some of the interesting fields where deep learning and neural networks can be applied are image and video processing, speech and language processing, healthcare, transportation, finance, manufacturing, and many more. In healthcare, they can be used to analyze medical images, such as X-rays and MRI scans, to detect and diagnose diseases. In transportation, deep learning models can be used to enable self-driving cars and other autonomous vehicles to navigate roads and make decisions in real time. The greatest example of self-driving cars that uses deep learning more often is the Tesla cars. Finance industries also depends on deep learning algorithms to analyze financial data and make predictions about stock prices and market trends. Another industry is manufacturing, where most of the works are done by robotic hands trained on deep learning algorithms doing most of the stuff more efficiently than humans. Despite its many successes and wide variety of applications, deep learning has its challenges and limitations as well. One of those challenges is the need of massive computing resources. Deep learning algorithms are complex in large scale and need specialized hardware to train them. This might not be ideal for small companies. Another challenges including the lack of interpretability and good training data. Many deep learning algorithms and models are complex and difficult to interpret, making it difficult to understand how they arrive at their predictions or decisions. Moreover, when there is a lack of good training data, the deep learning models perform really worse than some primitive machine learning algorithms. However, researchers and practitioners are actively working to address these issues and overcome these limitations. So, we hope that these challenges to deep learning can be resolved in the near future. With that said, we came to the end of this video. In the upcoming episodes, we'll discuss more about neural networks and it working in detail. Thanks for watching, and we'll see you in the next one.